Hello, everyone. Good afternoon, and thank you for coming to this session and making time for this. So today we'll talk about orchestrating perimeter security for your web applications. So we'll get right into it. Let me introduce myself. My name is Nihar Bihani. I'm a senior manager at Amazon Web Services in the perimeter security space. And I also have with me one of my colleagues, Jeff Lyon. He's way over there. He'll be doing a few demos for you today. So I want to just kick off by making sure you understand what you will learn and get out of this session before we even get started. So Jeff and I have 3 goals for this session. First, learn about the threat landscape, and we'll do a brief overview of that. Some of these things you may already be aware of, but it'll be good to get that backdrop of what are the different types of threats that are out there that could be potential threats for your web applications. We'll talk quite a bit and introduce several perimeter security and other AWS tools and services that you can use to protect you and your applications without the need to re-architect those applications. So we'll talk about how you can build layers of defense in front of the applications that you already have. And finally, we'll talk about if you have multiple applications, hundreds of applications, or potentially thousands across hundreds of accounts, how do you secure all of those applications and have a compliance posture at scale and have a consistent sort of security and compliance policies across all of those applications? So let's start by talking about the threat landscape. So broadly, for web applications, you can think about 3 different categories of threats. And for each one, there's a few examples that I've listed here. We'll start with the first one, DDoS, or distributed denial of service. And a couple of examples there are HTTP floods. So these are sophisticated layer 7 attacks that can target your application with legitimate traffic and with the intention of overwhelming the application infrastructure so that your real users are unable to access the application. Reflection attacks are essentially attacks that exploit the DNS system and are intended to send a lot of DNS requests that turn small requests into large payloads. So again, DDoS overall is intended to overwhelm your infrastructure and your application. Application vulnerabilities. So these are types of attacks that are targeting the application code that you've written or sort of the platform or the software that you're running that application on, such as Apache or Tomcat and so on. And so some examples there are SQL injection. This is malicious SQL queries that may be sent via the request to the backend database in order to extract data that is not supposed to be displayed to the users. Cross-site scripting, similarly, these are malicious scripts that are injected into your application using this type of an attack. OWASP is the Open Web Application Security Project. This is an organization that sort of puts together the top 10 most critical web application security risks. And there are a number of risks that they define as well that can be potential threats to your application. CVEs are common vulnerabilities and exposures. These are threats that may exist broadly on the internet that can impact multiple applications out there. And then the final category is bad bots. This is a category where the attacker is not necessarily trying to overwhelm your application, make it unavailable, but rather access data that's not supposed to be accessed, or access data in a programmatic way, such as your product catalog, your pricing information via a script, and sort of crawling your application. Specifically, the distributed denial of service or DDoS attacks, there are different types of attacks such as SYN flood, UDP flood, ICMP flood, and there are many other examples listed there. But the idea with these is that the attacker sends lots of requests from different parts of the world, so distributed across the globe, with the intent of overwhelming your application. So a real user, when they are trying to access the application, it's unavailable. So the question as an application owner, developer, or a security owner within your organization, the question you want to ask is then how do you protect your application from these threats? You could have different types of applications that are internet-facing. It could be APIs that you're vending, personalized content, dynamic applications that are interactive, where there's a request and then a response, and the response changes based on the type of request, or static assets that you're delivering, images and so on. And often the architecture for these applications is where the application is hosted in a server, could be a corporate data center, could even be in AWS, and end users reach out to, there's an internet-facing endpoint for end users to contact and access that application. But in that previous architecture, there isn't the layer of defense that you would need to mitigate the DDoSes or the web exploits or the bots that could be also targeting your application. So when you think about scaling your application and keeping it highly available and secure, there is a number of other considerations that you have to think through, such as authentication, encryption, TLS, and different layers of protection to make it more secure. On the availability side, how do you make it fault tolerant so that it's available? How do you handle the request capacity? How do you keep it performant so that when you have users across the globe, they are able to access it? So how do you route those users? And how do you throttle the bad users? And then having the visibility, the alerting, the monitoring, and the alarming so that you can fine-tune your security and availability and know what's happening. So building a baseline layer of defense, we'll start by introducing some AWS services that you can use to build the baseline defense. So 3 specific services that I'll talk about first. The first is Amazon Virtual Private Cloud, or Amazon VPC. VPC provides you logical isolation for your resources, where you can launch AWS resources in a virtual network that you define. And gives you the ability to have layers of defense or security, such as security groups or network access control lists. And when Jeff does a demo in a little bit, he will dive deeper into the security groups and how to configure that in a VPC. Amazon CloudFront is the other service. CloudFront is AWS's CDN, or Content Delivery Network. It has global presence with 150 locations around the world, and that gives you a lot of scale. It has locations very close to where users are, and with that many locations, CloudFront can easily scale up to any increase in traffic that your application may experience. It also provides SSL or TLS termination, shields your origin, so the users or even the attackers are contacting and talking to CloudFront, and then CloudFront is the one that's talking to your backend application. And it also caches your static objects, so it provides you resiliency. If for some reason your application is unavailable, CloudFront can still continue to serve the static objects. And then Route 53, which is AWS's authoritative DNS service. And Route 53 has algorithms that it uses to separate good DNS traffic from bad traffic or bad DNS queries. And it looks at characteristics of the DNS query and effectively develops a suspicion score for each DNS request, so that requests with a high suspicion score can be prioritized lower than a low suspicion score. Based on this sort of scoring, give you mitigation against bad traffic versus good traffic. So wanted to introduce a new architecture where, if you look from right to left, the Amazon VPC encapsulates your dynamic web application. So you're not actually changing the application that you may already have today. And that's where your EC2 instances or your load balancers and so on will run. But in addition, and the Amazon S3 bucket is where you have your static content. But fronting your EC2 instances and your S3 buckets is CloudFront and Route 53. And so your users are contacting CloudFront and Route 53, and then that provides the origin shielding and is talking to your backend. So specifically for DDoS, AWS also has a service called AWS Shield. And this is yet another tool that you can use. AWS Shield is a managed service that provides always-on detection and automatic mitigations that are in line to help keep your application available, so lower the downtime and keep the latency low. Shield comes in 2 different tiers. There is Shield Standard and Shield Advanced. Shield Standard is something that is available to all AWS customers at no additional cost. And Shield Standard gives you protection against the most common and frequently occurring network and transport layer attacks. And then Shield Advanced is a subscription-based service that gives you additional detection and mitigations for larger and more sophisticated DDoS attacks. It also gives you near real-time visibility into attacks. It gives you AWS WAF at no additional cost. WAF is the layer 7 DDoS mitigation service. With Shield Advanced, you also get a couple of additional things. You get 24/7 access to a DDoS response team, and also economic protection for any resources, AWS resources, that may need to be scaled up to mitigate a DDoS attack to keep your application available. So introducing Shield into this architecture, the only difference from the previous architecture we saw is now we have AWS Shield that is protecting the CloudFront and Route 53 resources. There are some specific advantages that you get when you're using CloudFront and Route 53 for DDoS mitigation on the AWS Edge network. So first, our proprietary Blackwatch system is sitting fully in line, and it inspects every packet before it reaches CloudFront or Route 53. When the traffic is bad, it automatically drops that traffic. When traffic looks suspicious, the Blackwatch devices will give it a suspicion score and rank the traffic based on that suspicion score. This helps, again, keep your application available and also lower minimize the risk of false positives. Because these systems are fully in line, the most common volumetric attacks are mitigated in less than a second. There is no need to wait for detection or send the request to a remote scrubbing center for mitigation. We also have a unique way of mitigating SYN floods without the need for SYN packets to be shaped or proxied. Blackwatch connections are challenged and then handed off to the service, which allows mitigation of these attacks at scale and with a high degree of accuracy. And then to mitigate the largest known volumetric attacks, we're able to use a combination of DNS traffic shaping as well as anycast routing. And this allows us to take advantage of the vast global edge network and direct traffic at a granular level and control where the traffic goes in the event of an attack. So a couple of examples of recent significant attacks that we were able to mitigate. In March earlier this year, one of the Shield Advanced customers they experienced a 1.4 terabits per second memcached reflection attack. This is where an attacker can send spoof packets to open memcache servers, and we were able to successfully mitigate this using CloudFront. Another even more recent example is just earlier this month, there was a 20 million requests per second attack to another Shield Advanced customer that we were able to successfully mitigate using some of the traffic shaping techniques that I talked about with DNS, traffic routing, and anycast routing. As a Shield Advanced customer, you also get near real-time visibility into a lot of these attacks as they occur. But when you look at these numbers, one thing to think about is, as an application owner, scaling your application to these levels of traffic is just impractical. And so that's where the AWS Edge network can give you the scale to keep your applications highly available, and the economic protection that Shield Advanced provides. When we have to scale those resources for you, you don't have to pay the extra expense for those resources, and your application stays available. The application acceleration, these mitigations are often in line, and the Edge network, in the way we do routing, can help with the acceleration of your real users. And then all these services are also integrated with the rest of the AWS infrastructure. So at this point, I'll invite Jeff to give you a demo, our first demo on security group automation.
All right, thank you everyone for coming out. Just to get us started, I want to give a quick introduction to myself and then dive right into the demo. My name is Jeff Lyon and I lead operations for AWS Perimeter Protection, which includes the AWS DDoS response team. So I'm going to do 3 different demos today to give you a better sense of some of the concepts that we're talking about and how you might be able to apply them when you get back to the office. So let's jump right in. Got ahead of myself. There we go. We have another slide. So every one of these demos, we put up a slide that has blog posts. So the blog posts make it so that you don't necessarily have to follow along with every step of what I'm doing. You can go ahead and just go to these posts and follow the step-by-step instructions to implement each one of these demos. I know a lot of you are taking photos, but you don't necessarily have to. These videos will be on YouTube in a couple of days. You just go to YouTube, pick out the URLs, and then follow along to implement this yourself. So the first demo I'm going to do is to automate the updating of VPC security groups such that when you're building this perimeter defense layer, only Amazon CloudFront is able to talk to your application. So you don't want the attackers or whoever else to go through the side door if your intent is that you're using CloudFront to proxy requests. So that's what this demo is all about. So this architecture probably looks familiar to you. This is what Nihar put up a few moments ago. And I'm going to add some integration here with a Lambda function that you would integrate into your own account and then have that Lambda function triggered off of an SNS topic. That SNS topic is managed by AWS. You don't have to build it yourself. And you're going to use that so that every time we update the IP ranges on our network, your VPC security group is automatically updated. In that way, in near real time, you're only accepting traffic from known Amazon CloudFront IP ranges. Okay, now let's do the demo. So first thing I want to do is show you the IPRanges.json file. So this is something you can go to right now if you wanted to check it out. It's on the public internet. And we publish all of the IP ranges for every Amazon service in every part of our network. So I could actually just do a Control F here and say CloudFront and see there's 67 different IP ranges that need to be in the VPC security group as of this moment. So what I'm going to do is I'm going to build the Lambda function. I already have that staged out here just in the interest of time. And the blog post that I mentioned has the Lambda function, so you can literally just copy paste it. You don't need to know any code. And in the Lambda function, we have an IAM policy that's going to allow this Lambda function to only access CloudWatch logs and parts of EC2, specifically the security group. So I'm going to click on View Permissions, and this is the execution role that gets created as a result. So this is what the Lambda function is going to be authorized to do. We'll click off of that. Since this is already built, the next thing I need to do is to actually associate the Lambda function to a trigger, specifically that SNS topic that I mentioned. So I'm going to go over here to the command line. So we have to use the command line to do this since the SNS topic isn't in the demo account. I already have the CLI command populated on the screen. I'm just going to execute that real quick. And you see I have a response from the API. The next thing I need to do is to update a resource policy to add permission so that when there's an update to IPRanges.json, your Lambda function is automatically triggered. So I'm going to execute that. And that took. So let's go ahead and just refresh my screen. We'll click on View Permissions. And now you can see I have a function policy. So now we successfully built a Lambda function with an execution role and a function policy. So the next thing I want to do is to show you how we actually have this integrated with VPC. So the way that the Lambda function knows which security groups to update, if I go over here to the EC2 management console, I have a VPC security group, this one that says SGALB, and it's tagged CloudFront. So any security group tagged CloudFront is going to be updated when this function runs. So let me go ahead and test it out. Okay, and execution succeeded. You can see here it says updated 1 HTTPS security group. So let's go ahead and take a look at it. I'm going to click on my inbound rules. And you can see here that I have all kinds of different IP ranges that were just added to the security group. And that concludes this demo.
Thanks, Jeff. So now that we've talked about the volumetric attacks, DDoSes, and using CloudFront, Route 53, as well as some of the demo that Jeff showed in terms of VPC and locking down the security group, the other question that, as an application developer or an owner, you end up asking is, beyond just the volumetric aspect, how do I have more control on the traffic that I should be allowing to my application? So from a security perspective, some of the things you want to think about is, how do you block application exploits, people who are trying to access things on your application that you don't want them to access, bad bots, and how do you meet your compliance requirements that may be specific to your organization and that you need to adhere to. So a common solution for these considerations is using a web application firewall. A web application firewall can inspect the HTTP or the layer 7 traffic that's directed at your application, and then take action based on rules that you may define or conditions that you specify. The other question that developers ask us is, how can we make it easier for them to sustain the compliance standards that they need to adhere to? Compliance requirements change over time. There is different types of compliance requirements: PCI, OFAC, HIPAA, GDPR, and many others. And also, when you have lots of applications distributed across multiple accounts, how do you make sure that all of the accounts, the new accounts that may get created, all of your resources and applications, which may change over time, can stay in compliance? So some of the tools that we have to help with the security and compliance aspects of your applications. The first one is AWS WAF. WAF is a web application firewall service. It's a layer 7 HTTP inspection service, and it helps you customize the security to your application. You specify rules, and within these rules, you create conditions to match on certain things and block traffic or filter traffic. You can also utilize, instead of writing your own rules, you can utilize managed rules that are provided by AWS marketplace sellers. There's a number of rules that already exist, and you can use those as a quick and easy way to get started with WAF. There's different types of metrics that WAF provides for visibility, and I'll dive deeper into that. And then there's also, since all of the WAF functionality is available via APIs, you can actually automate a lot of the configuration of rules by looking at your web application logs, analyzing those logs, and then creating new rules and submitting those to WAF so that WAF can use those rules when it sees traffic coming to your application. So deploying AWS WAF, you can use AWS WAF with 3 different AWS services today, and it's natively integrated with Amazon CloudFront, AWS Application Load Balancer, and Amazon API Gateway. The same functionality for AWS WAF is available across all 3 of these services. So even if you're not using CloudFront for any of your internet-facing applications or APIs, you can still attach a WAF web ACL with API Gateway, for instance, or your ALB, and still have the same protections in place. So some of the WAF capabilities, just to get a little bit deeper into the details there. First is blocking bad traffic, and there are some checkbox solutions that WAF already has, such as SQL injection conditions or cross-site scripting conditions. These are some of the attack vectors we talked about, and you can turn these on very easily and quickly for your applications when you get going with WAF. We also have published several CloudFormation-based security automation templates that utilize Lambda and look at logs. So these are pretty easy to get started with as well. There is, for instance, an OWASP top 10 CloudFormation template and a blog post that's available that you can use to get protection against the OWASP specified top 10 vulnerabilities. And then the marketplace managed rules, there's a number of rules there for OWASP top 10, CVEs, reputation IP lists, and several other rules specific to your application, for instance, WordPress rules, and so on, that you can easily turn on. There is also, for writing your own rules, there's also features such as IP matching or geo-IP filtering that's available, where you can specify matches on and regular expressions and string matches on things like query strings or cookies or any part of the header or even the body. And so you can get very granular in the way you want to specify the rules and which traffic you want to block or allow. Size constraints is another one where if you know that your uploads, your posts are only going to be a certain size and never over that, then you can put size constraints as well. And then WAF provides a number of visibility and debugging options. So you have CloudWatch metrics and alarms for traffic that's blocked or traffic that's allowed. And you can set different thresholds on these. There's sample request logs, as well as more recently we added comprehensive logging for every request that's inspected by WAF, whether that's directed to your CloudFront, ALB, or API gateway. Getting into the compliance area a little bit, many of you may be familiar with PCI compliance, which is just the payment card industry, and this requires that you use a web application firewall. AWS WAF is PCI compliant, so using WAF can help you towards that goal of achieving PCI compliance. You can use managed rules from the marketplace for OS protection, or you can also use the AWS template, the CloudFormation template that we have published. For OFAC, and OFAC is the Office of Foreign Assets Control, this stipulates that you block traffic from certain parts of the world, certain countries, from accessing your application and your resources. You can use the geo conditions that WAF provides to be able to implement that easily. We're also working on a CloudFormation template for this, so keep an eye out for that. This should be available soon. HIPAA, so if you're doing any work in the healthcare industry, HIPAA is the Health Insurance Portability and Accountability Act, and GDPR, that's the EU General Data Protection Regulation. WAF is GDPR ready. WAF is one of the services in scope for HIPAA. So again, just by using AWS WAF, it can help towards achieving some of these compliance or standards that you may need to adhere to. For more details about compliance, you can go to the AWS website where our compliance program descriptions are posted publicly. And then in terms of logs, so AWS WAF does, as I mentioned, we added comprehensive logging recently. So every single request that goes through AWS WAF and is inspected by WAF is logged. And we do this logging by sending that request log data to Kinesis Data Firehose. And it's sent in JSON format. It includes every single request, all the request headers along with any WAF metadata that's included. And you do have the ability to redact any sensitive fields that you don't want logged. The thing that customers have really liked about using Kinesis Data Firehose is that they can then send their log data to multiple destinations, such as Amazon S3 for long-term storage, for auditing and compliance, for instance, or Elasticsearch or Amazon Redshift, which are some of the solutions for more analytics. You can also send it to our partners, such as Splunk or Sumo Logic. And so there's a number of different options available there. So I'll invite Jeff again to do a demo on the log analysis for AWS WAF using the comprehensive logs feature that I just described.
All right, great. As I mentioned in the last demo, each time we get up here and give a demo, we're going to offer you the blog posts that allow you to implement this yourself. And so this particular demo has a lot going on. There's a few different blog posts that you might want to reference. And there's a lot of information in these blog posts, but I'm going to try to make it simple so that you can follow along real easily and get started once you get back to the office. So let's jump right in. I do have another reference architecture. Again, this one should look fairly familiar. It has the Amazon CloudFront, Route 53, but we also added in AWS WAF. And so in the demo, we're going to show you how to use AWS WAF full logging with Amazon Kinesis Data Firehose to send your logs to Elasticsearch and then be able to analyze those logs using Cabana dashboards. And so in this demo, I'm actually going to work right to left. I'm going to show you the Elasticsearch component, the Cognito component, and then start talking about how the logs get integrated and analyzed. Okay, let's get right into it. So again, to help make things really quick and easy for us in the demo, I've already created an Elasticsearch domain. These are pretty easy to do, though. They take about maybe 10 or 15 minutes to build. 10 minutes of that is about propagation time. The 5 minutes is just you configuring how you would like to have your Elasticsearch domain. This one has a public endpoint, so you can get to it over the internet. I wanted to have presence in 2 availability zones, 3 master instances to avoid split brain. And I made some other specifications here as far as encryption, the type of volumes that I would like to have, and I specified integration with the Cognito user pool and identity pool. And this is really easy to build. I want to show you what that looks like. So the reason to have Cognito integration is so that you have user and password authentication into Cabana. Without Cognito or without some other type of integration, the way you would control access to Cabana is using the IAM policy that's on the Elasticsearch domain. So what you want to do is create a user pool and an identity pool. And I largely just use default configuration for these pools. So for the user pool, I created it. I went ahead and added myself as a user, so just added Jeff Lyon as a user of the user pool. And I also configured a domain name, so it's WAF logs demo. And that was really all I had to do with regard to the user pool. And the identity pool was even easier. I literally just created it. And then to get everything integrated, there's essentially a wizard in the setup of the Elasticsearch domain that takes care of the rest for you. So let me go back to Elasticsearch really quickly. And I'm going to configure cluster just to show you what those options look like. But you just come down here, you specify your region, you say I have a user pool, you specify that user pool. Same with the identity pool. You're given an IAM role to complete the integration, and then everything is done for you from there. And the very last thing that I did was, let me back out of this. I modified the access policy. And so the access policy you see here on your screen has a resource, an AWS principal, which is the Cognito auth role. So using that role that was created when I created the identity pool, I took that ARN, I put that into the policy for the Elasticsearch domain, and now everybody must authenticate before they get to Cabana. So let's go back in there. I actually want to show you what Cabana looks like if you're not familiar with it. It's going to let me right in because I already authenticated via Cognito before this demo. But the first thing I did to get this set up, just following along with the blog post, so if you miss anything, don't worry about it. It's in the blog post. You go to DevTools here, and you create your mapping. And so you just copy-paste this directly out of the blog post and click this little green arrow. And that's going to create a mapping to associate the format of AWS WAF full logs with the Elasticsearch index to be able to browse it in Cabana. And then there's also, if you go into management here, there's some saved objects. We give you dashboards and visualizations that are pre-configured so that you can just get started right away. So now I want to move over real quick to the WAF side of things to show you how that works. Actually, before I get into WAF, let me show you the Firehose, because I need to get the Firehose set up first. So I'm going to go to the Kinesis dashboard. And I already have a Firehose delivery stream set up, so I'm just going to click on that. And again, the blog post will tell you how to set this up, but it was really easy to follow along with. I just defined what I wanted to call it. I used source of direct put. I specified an S3 bucket because I also wanted to copy all records to S3. Set some buffer conditions, specified how I want to configure compression and encryption. And then I configured my domain. This is my Elasticsearch domain right here, AWS WAF logs. I specified an index of AWS WAF, rotation every day. So there's a new index that's getting created with a date stamp. Type is WAF log, use the default retry duration, and specified buffer conditions of 5 megabytes or 300 seconds. So every 5 megabytes that are generated from AWS WAF or every 300 seconds, it's going to send that information to Elasticsearch. And now I'll jump right over to the WAF console here to show you how we turned on the logging. But essentially, you just click on your web-ACL, you click on login, and I already have this set up, but if you didn't have it set up, you would just click Enable Login, specify the data Firehose that you want to send your logs to, specify whether you want to redact any fields, and it's that simple. Then coming back over here to Cabana, I want to show you what this looks like now that I have my data inside of it. So I'm going to specify a time range of, let's do the last 4 hours. And I use a small botnet that I maintain just to attack myself and generate some data in here. And you can see that there were a lot of requests that were generated. There's a total of 303,000 hits you see at the top of my Cabana dashboard. And then it shows you all the available fields that are in the log. And you can just click on this to see top talkers around different dimensions. So we see that 100% of the traffic was US. You can see what the top IP addresses were. You can see that it was 100% GET requests. And so you can just browse your data in this way. So here's the visualizations that were automatically given to us when I uploaded that configuration file from the blog post. But if you wanted to create your own, you would just click this button here, specify the type of visualization that you want to create, and create your own dimensions against the AWS WAF log data. But using that configuration that's provided to you in the blog, you're given the dashboard that looks a bit like this. So what I was doing was I was sending an attack toward my website, and I'll show that to you in my next demo. I had a rate-based rule that was enabled, and so in under 2 minutes from the time that I attacked myself, the rate-based rule engaged and started blocking those requests. So you can see here, there's some requests that were allowed, some that were blocked. So for a small period of time, requests were being allowed, and then the blocking kicked in. All right, and that completes the AWS WAF log demo. I'll pass it back to Nihar.
All right, thanks, Jeff. So yeah, Cabana is just one of the options that Jeff demoed right now. You can also send it to Redshift, Splunk, Sumo Logic, as I had mentioned earlier. So there's multiple options available there. If you have many applications that are distributed across lots of accounts, and sort of a decentralized model in your organization where developers are creating new applications, spinning up new accounts, the other question that you end up asking is, well, how do I organize all of these policies so that everything stays in compliance? The challenge is there. Lots of accounts and resources being created. It's really hard to manage that without an automated solution. If humans are involved, it's going to be error prone. New applications get created all the time, so sort of keeping track of that can be challenging, and making sure that everything is consistently and always protected from day one. And then having central organization-wide visibility into threats. So these are some of the things that become difficult and complex when you have lots of applications across many accounts. So coordinating these security policies, there are tools that AWS has, and you could actually put this together yourself. And one of our customers did this. So one of our customers, Magellan Health, they used a number of different AWS tools to create an automated, centralized security framework to keep track of all of these resources and all of these accounts that were spun up within their organization. So I'll walk you through briefly with this. If you look from the top left, they have an AWS code pipeline where they commit code to their Git repositories. They use code build to execute that code, and then they have CloudFormation templates that keep track of the accounts and the configuration updates. The configuration updates are sent via CloudTrail to CloudWatch. CloudWatch emits alerts. Those alerts are then received by Lambda, and Lambda functions then make sure that any new resources or any new accounts, that Shield protections and WAF rules are put in those resources and accounts consistently and in an automated fashion. Their software also makes sure, the system also makes sure that it sends a SMS notification to their security team. So all of this works really great, and they did a great job building this. And it achieves sort of that purpose of keeping track of all of the security policies, keeping everything in compliance. But this is a lot of heavy lifting, and you shouldn't have to do that. And we heard similar feedback from a lot of other customers, and so that's why we introduced AWS Firewall Manager earlier this year. And the Firewall Manager service does exactly that, where it simplifies the management of your WAF rules across multiple accounts and across hundreds of applications. Make sure that you stay in compliance with all of those mandatory rules, whether they are because of, for instance, OFAC compliance, where you have to make sure that every single application in your organization, there is no traffic coming from certain list of countries, or any other such as OWASP top 10, and make sure that every new application has OWASP top 10 protection always there. And then this also allows you to have a rapid response to any incidents or threats that might occur across any application in your organization, because you're managing the security of all of your applications using a single policy that's defined in the Firewall Manager service. This is sort of how Firewall Manager works. So if you look at the bottom left of the screen, Firewall Manager is integrated with AWS organizations. And there's an organization's master account who's the administrator for the Firewall Manager service. And they are the one who create Firewall Manager policies. And then Firewall Manager subsequently talks to AWS organizations to watch for new accounts that may be added to your organization, or any accounts that may drop out of your organization. The policies can be scoped to only certain accounts within your organization, or you can use tagging and tagged resources and scope it down to only the resources you want to protect via that policy, for instance, all your production resources. The Firewall Manager also listens to configuration updates to CloudFront or Application Load Balancer anytime new resources get spun up for new applications across any of the accounts that are in scope of the policy. And via the Lambda function, AWS Firewall Manager will create WAF rules and put those WAF rules in place as soon as those resources are created. It also helps with compliance and ensuring that there is no regression. So if any developer in your organization by accident deletes their WAF rules, the Firewall Manager service will put the WAF rules back in place. So you're always in compliance. So adding on some of the security and compliance tools that we talked about, WAF and Firewall Manager in particular. So if you look at this picture, this is sort of representing two different accounts, so multiple accounts. If you look at just the top right, it'll look familiar to the picture we saw earlier. But representing multiple accounts, we added Shield to CloudFront and Route 53 to those boxes. We added WAF and introduced WAF for security policy filtering. And then WAF allows you to block the bad traffic and allow the good traffic. And then Firewall Manager is the final tool that we talked about, where Firewall Manager can now consistently, across all your accounts, make sure that the same WAF rules are in place so that all your applications are protected. So I'll invite Jeff again, and he will give a demo of Firewall Manager and show you sort of how Firewall Manager works and how you can configure that, what some of the prerequisites are.
All right, let's get right into it. So there's many types of customers, many types of organizations with compliance or other requirements, large and small. My requirements are actually quite small, so I'm going to be showing you a very small website that I maintain, but show you how, if you are an organization who has many more applications across AWS, how you can use these concepts to orchestrate security and make sure that your WAF rules are consistent across all applications. So let me, again, show you the demo resources. Just put this up on the screen for a moment. Firewall Manager is really easy to get started with. We have a blog post here when the service first came out, just showing you what is the service, how do you get started, what are the steps. But once you go to this link, you'll find that it's really quite simple, and I think you'll see that in the demo also. All right. So let me close out some of these tabs that I no longer require. And I will show you my website. So this is the jefflyoncatblog.tk. So there's not a whole lot going on here, but this is a WordPress website. And one of the challenges with this WordPress website is if I go here to WP admin, it's going to let me log in. So if there's any kind of vulnerability in this application, then an attacker could come right to the login page and cause any type of problem. So say for sake of example that you're an organization who has many WordPress sites. You might have many other types of applications, but I'll just use this for the demo purposes. And you want to make it so that nobody can access this WP login page across any of the applications for which you're responsible for as a security administrator. And you want to make sure that you're not relying on each individual team who maintains a website to do the right thing and have the right rule in place. You as a security administrator are able to maintain that for them. So let's get started by going into the FMS console, or the Firewall Management Service. So I actually have two different accounts. So the account that I've been operating in is my demo account, and the second account that I'm in is my Firewall Manager demo. So I'm going to sign into this account. And the only thing I have in this particular account is this account is my AWS Organizations Master. And the other thing that I've done is enable AWS config across both accounts. And then as the AWS Organizations Master, I was able to go to, let me go to WAF and Shield actually. And in this console is where you'll find AWS Firewall Manager. So I'll click on AWS Firewall Manager. And you see here that there's a couple of green checkboxes, and these are the prerequisites. So it says your account must be in an organization. It is. It's the master for the organization. And you must designate an account as the AWS Firewall Manager Administrator, which I've also done. But if you haven't done it for your own account, getting that done is quite simple. You just come over here to Settings, and if you didn't already have an account specified as the admin, you'd be prompted to specify an account. Just for simplicity in our demo, I've gone ahead and specified myself as the admin account. So now what I'm going to do is go ahead and create a security policy that makes it so that nobody can access that WP login page on any of the WordPress sites for which I'm an administrator. And for demo purposes, I have one site, but if you had 1 or 10 or 100, wouldn't matter. We'd have that firewall policy applied across all of those sites. So let me come over here to Security Policies. And I'm going to change my region to CloudFront because I'm using CloudFront distributions. And I'm going to create a policy. And in the policy, I'm going to specify create an AWS Firewall Manager policy and add a new rule group. And I've already have Global CloudFront selected, and I'm just going to click Next. Now the next thing I need to do is create a condition. And the condition I want to create is a string or regex match condition, but I'm going to use a string. I click Create Condition, and I'm just going to call this block string. It's going to be a string match type. I'm going to filter on the URI. Match type is going to be contains, so anything containing WP admin or WP login. So I'll just do WP admin for this one. And we'll convert to lowercase. That way someone can't, for example, use camel case to try to get around the firewall rule. So let's do WP admin. And I'll create another one, actually. So let's do the same thing. Let's do URI contains, convert to lowercase, WP login. And I'll add that filter. So I've successfully created a string match condition. And I'm going to create rule. And I'm just going to call this string rule. And I'm going to add the condition. So I'm going to say when a request does match at least one of the filters in, let's select string match condition, block string. So it needs to match one of these filters, and that rule is matched. So I'm going to click Next and create a rule group. We'll just call this demo group. And we'll select the string rule. We'll add that to the policy, and the action will be block. Okay, and so I've created the demo rule. And I'm going to call this policy demo policy. Okay. And I'm going to say create and apply to new and existing resources for CloudFront distributions. Okay, let's review the work that I've done so far. Okay, we have our rule group. All accounts are in scope. I'm going to confirm that config is enabled, and I'm going to click Create. And you can see here I have a success. So I've created my AWS Firewall Manager policy. So now let me log out of this account. I'm going to go back into my demo account and see if I can find the rule. So I'll come over here to WAF and Shield. I'm going to, switch to CloudFront. Okay, so I have this rule that was created called block strings. And actually, that was one that I had created before. And it looks like I have a change propagation delay, so that hasn't gone through quite yet. But the expected pattern that you would see is if you went to, let's go back to my demo blog here. And I went to WP admin, you should actually see an error page once that rule completes the propagation. Okay, and that completes our demo. Let me just switch back to the slide. I want to thank everyone for coming. If you please remember to submit your feedback via the reInvent app. And also, if you're interested, if you have any Q&A or any questions or just want to meet Nihar and I, please come to the meet and greet session, which is immediately after this one here, in the speaker lounge on ARIA East, level 1 Willow Lounge. Thank you again for coming.
Great. Thank you very much.